Hi, in this video, we are going to be looking at SQ1 sequence formulas. And so we are given three sequences here, and we have different tasks for each of them. So for part A, we're looking at the sequence a sub n is n squared plus 1, and we want to find the first 5 terms of the sequence. And so first of all, we have to decide how we want to start. And so by convention or using whatever we prefer, I'm going to start with 0 because I just feel like it. You can do whatever you want. The first term of the sequence a sub 0, which is going to be 0 squared plus 1 equals 1. The next term should be a sub 1, which is 1 squared plus 1 equals 2, and so on. A sub 2 is going to be 2 squared plus 1 equals 5. A sub 3 is going to be 3 squared plus 1 equals 10, and then a sub 4 is going to be 4 squared plus 1 equals 17. Right, and that is our first 5 terms, again remembering that we started at 0. For the second part of this problem, we are looking at a closed form for the sequence 5, 20, 80, 320, and 1280. And I want to know what sort of a sequence this is. So first we have to look at this sequence and see if there is some sort of pattern. So just looking at it, we know the difference between 5 and 20 is 15. We also know that 20 is 4 times 5. The difference between 20 and 18 is not 15, but 80 is 4 times 20. And then we look at this, it's 320 is 4 times 80. 1280 is 4 times 320, so that suggests our pattern. And it's worth noting that these aren't the only possible patterns, but this one certainly stands out. So we want to increase by factors of 4, which suggests a geometric or exponential kind of growth. And so we once again need to establish our convention. So starting at n equals 0, we have with the a sub n is, well, we first of all want a 4 to the n component of this expression because we are increasing by factors of 4. And then when n is 0, right, when n is 0 at our starting point, the value of the sequence is supposed to be 5. 4 to the 0 is 1. So that makes sense that we start with a coefficient of 5 times 4 to the n. And then we can check that 5 times 4 to the first is 20. 5 times 4 squared is 5 times 16, which is 80, and so on. So this is a perfectly good closed form for that captures these terms. And for the last of these, I look at the recursive form for the sequence -5, -1, 3, 7, 11. And what I notice here is that each term is 4 more than the previous term, right? -1 is 4 greater than -5. 3 is 4 greater than -1. 7 is 4 greater than 3, and so on. And so this suggests a recursion relation where each term is 4 greater than the previous term. And then the starting point of the sequence is -5. So I need to say that. Again, I'm starting with 0, but you can start with 1 or whatever you choose, is -5. And if we looked at this, this recursion says, all right, A0 is -5, A1 would be 4 plus -5, which would be -1, A2 will be 4 plus -1, which will be +3, and so on. All right, thank you very much. I will see you in the next video.